In this series of videos I've been repairing and restoring this Addo Model 9 vintage mechanical calculator. And it's not a typical general purpose calculator. This was meant for financial use, and the Model 9 was intended for use in the UK currency system. So it's got some peculiarities that are geared specifically towards that. So in this video we'll see if this actually works. I did have a problem with it, didn't video it really, but the problem was that if I tried to get the turtle from the machine, it failed. The key would stick down, and that was really, the cycle just wasn't quite completing. I think I pointed this out before, that the cycle control cam that's located back here wasn't going all the way around and completing the cycle. And it wasn't because the motor was turning off too soon. Mechanical devices like this that run at high speed, the designers kind of accounted for the inertia of the machine. So it was turning off at the right time, but the machine was just too tight. So all I did was just use it for a while. I just held down the plus key, hold down the plus key and it keeps cycling. Kept running it through a few calculations, held the key down, let it cycle, and now it's freed up and the control cam goes all the way to the end stop for each cycle, and the turtle key pops back up as it should do. So these keys along the top are the mode control keys. We've got a repeat key, so if we want to repeat the process we can push this down and latch it, and it will cause the characters that you put into the keyboard to be retained at the end of the calculation. If you have this up, they'll all be cleared each time you press one of the control keys. This can be handy. You can actually do multiplications and divisions on this if you want to, by just repeating a process. So for example, if you want to multiply something by 5, enter the number you want to multiply, push down repeat, and then just process 5 times. So in other words, you just add that value 5 times, which is, so that is actually how the more sophisticated calculators work. They just repeat certain processes more than once. So you set the number of times you want to add, for example, which is just your multiplier. Start the machine running, it will multiply that number of times and then stop. And that's all they do. That's all really multiplication is, of course. Same with division, you just subtract a number a certain number of times. You can do the same thing with these, of course. You just need to keep track yourself as to how many times you've cycled the machine. The next key along is the clear key. So that clears the keyboard, but it also clears the accumulator. Now, I said in previous videos that mechanical calculators like this work in a very similar way to the electronic versions that followed on. And underneath, you can't see it, but underneath the keyboard there's a series of slides, and they are used to retain the previous values and results of calculations. That's how the machine stores values, which we'll have a look at in a few minutes. But of course it means that the machine needs to be able to store values internally. So when we enter a value, that's used as an input value. But in order to add something to that, because of course that value will be cleared when we first press the plus key, but it hasn't had any number to add to that yet. So when we put the second number in, it must still have the original number somewhere, and that's stored internally. On top of that, if we're doing a running total, it needs some way to process the accumulated number, and again that's stored within the accumulator. It's a mechanical accumulator. It's a series of slides, and in addition to just storing the number, they also act as the processor. So they effectively work as the CPU in effect for the device. They will allow values to be carried or borrowed depending on whether we're adding or subtracting, and also in a calculator like this that has some oddities because of what it was used for. It takes the oddities into account. So for example, this one deals with pounds, shillings, pence, farthings, that sort of thing, and this mechanism will take that into account. So the clear clears both the keys that have been entered and also the internal accumulator. There are two subtract keys, but this is the big black one in the center is the one that we're interested in. That will just do a standard subtraction. Handles negative numbers in a bit of an odd fashion, but normally it's not really used for general purpose mathematics, so it doesn't matter. The next key along is to allow us to see the intermediate totals. So if we are entering numbers and adding them, we might want to look at the current subtotal. So we can use this key, and that will print out the subtotal. All the values of this outputs are on paper, of course. There is no indicator other than the paper printout. But this key, while it will show the current total, it does not clear the accumulator. Whereas the key on the right will show us the current total, and also it will clear the accumulator. So this is subtotal and then grand total, and the grand total will clear the internal register. Other oddities with this are, if we look at the keys, you notice they're in coloured columns, and this is because, as I said, this is for UK currencies. So this these three columns here are for entering pounds. These two columns are for entering shillings, and this column and these two keys are for entering pence. And then we have three keys down here that are for entering fractions of a pence or farthings. So these keys act very much like a decimal system. So they're all, you enter the number you want, so 2, 3, 4 for example, and this is kind of a decimal part of the system. This is where it gets a bit weird when we start entering shillings. There are 20 shillings in a pound, so the biggest number of shillings you will ever enter is 19. So that's why all these are 1, because this column is always going to be either nothing or a 1. So it doesn't matter which one you press, you're just entering a 1. And then a 1 through 9. So 1, 1 for example is 11, 1, 2 is 12, 1, 9, 19 of course. And then pennies. Obviously we have 12 pence in each shilling, so the biggest number we're ever going to enter in terms of pence is 11, and hence we have the values 1 up to 11. And then we have farthings, so 1 farthing is a quarter of a pence, hence the quarter on this key. 2 farthings, half a p, and 3 farthings is effectively 3/4 of a pence, and then you go up to 1p of course. Okay, so that's what all the keys are for. We'll now do some calculations, and I'll move the camera, and I don't know if the printing will come out. I have taken a standard, this is ribbon for teletype, and I've sliced it lengthways. They're normally 12mm wide, but I sliced it lengthways to give me an 8mm ribbon. It is printing quite clearly. I also made up a paper reel holder, and that was missing, and of course I fitted a paper reel. So it is printing quite clearly, but I've checked on the camera and it's not really coming across very well, so I'll try turning the lights down a bit and hopefully it will stop washing out the printing, but it is printing quite nicely. So I'll move the camera so you can see the paper more clearly, and then we'll carry out some calculations. Unfortunately I can't get everything into the shot while being able to show you the paper clogs up, so I'll tell you which keys I'm pressing, but you'll see the output on the paper. Okay, so for our first calculation we'll try adding 19 shillings to 2 shillings. So 19, I'm entering 9 shillings, and we press the plus key, and it's now showing 19 shillings. It's not showing on the camera viewfinder, so I'm going to try turning the light down. I don't know if this is going to help much, but hopefully it will enable you to see what's being printed. Seems to be about as good as it's going to get. Hopefully you can see that. It is quite clear in real life. I don't really know why the camera can't pick it up, but it's showing 19.0. And another thing, as I said before, the leading columns are not shown as leading zeros, they're just not printed at all. We'll now add 2 shillings, so I'll press the 2 key. The keyboard is clearing, I don't have the repeat key pressed down, so I'll press down the 2 shilling key. I'll press plus. Now it has added these two numbers together, but it hasn't shown it yet. It's now showing as the first row is 19, the second row is 2 shillings. It has added those together, and if we want to look at that total, we can either press the grand total key or the running total. So I'm going to use the running total, but because of the way the mechanism works, I need to do a dummy cycle. So I'll press the plus key again. Nothing much seems to happen, but that's processed the full calculation. And if I now press the running total key, notice we're seeing £1 and 1 shilling, which is exactly what it should do. But it hasn't cleared the accumulator because I used the running total key. So I'll add 3 shillings, press the plus key, and notice we've now added 3 shillings to the running total. And if I now do the same thing, dummy cycle, and press the running total key, we're getting £1 and 4 shillings, which is correct. £1 and 1 shilling plus 3 shillings is £1 and 4 shillings. If we want to subtract, we can now enter, I'll do 2 shillings, and we'll press the subtract key. Notice it's showing a minus sign at the right hand side to say that we're subtracting. And if we now do a dummy cycle and press the running total key, we're getting £1, 2 shillings. If I now add, we'll add 10 shillings for argument's sake. In fact, we'll add 11 shillings. And we'll do a dummy cycle, and this time I'll press the grand total key, and we're getting £1 and 13 shillings, which is correct. So in other words, it's working. We can add, we can subtract, we can look at the running total, we can look at the grand total, and everything is working the way that it should do. I'll just move the camera back. Okay, well hopefully you could see the text. It's, as I say, not looking very clear on the camera viewfinder, but it is quite nice and clear in real life. So the calculator works, we can add, subtract. You can see it's reasonably quick, it doesn't take any appreciable time to do the calculations, and it's quite flexible. We can add numbers, subtract them, keep a running total. We can do repeat, so if we want to do a repeat, we'll do a multiplication here. We press down the repeat key, but the first thing I want to do is enter the first number. So if we want to, for example, multiply 12 shillings, then what we would do is normally enter the number we want and press the plus key. But if we now press the repeat key, it's going to repeatedly add 12 shillings to the running total. So we'll press the plus key, and you'll notice this time it won't clear the keys. So the keys are still down. It's showing as a 12, another 12, another 12. So that's 3 12s. We can now clear this if we want to, or just keep going. But if we clear this, do one more, so that's 4 12s. Do a dummy cycle, a grand total, and it's showing us £2 and 8 shillings, which is correct. So we've multiplied 12 shillings 4 times. So you can do multiplication, you can do division, and it's quite a nice little machine. It's nowhere near as noisy as I thought it would be even quieter with the case on. So what I'll do just to finish off this series is I'll put the case back on, we'll run it up, and you'll see how it looks when it's complete. So that's how the calculator looks when it's been dressed, and as you can see, it looks quite nice. I still have a bit of cleaning to do on the case, still a bit grubby, but it's come up very nice. The keys are all nice and clean, they're all complete, none are chipped, and it's working extremely well. So do one final calculation, and this time 19 shillings. And as I said, it's surprisingly quiet. It's quite, it's not silent, but it's quite a subdued noise. And we can now add to that value, in this case we'll add 12 shillings, do our dummy cycle, running total, And you can see here I've been adding up quite a few numbers, so we'll clear that. That's cleared the accumulator. 19, and this time we'll add £1 and 1 shilling. Do a dummy cycle and look at the running total. So as you can see, it's working very well. It's doing exactly what it's supposed to, and it's surprising how well these come back to life. This is almost 100 years old, so it's working extremely well. It looks nice, and it's quite a lot of fun to work on. So if ever you see one of these and you're tempted to buy it just for fun, I strongly recommend it. As I say, they're a lot of fun to work on, and you can learn a lot about engineering and even electronics from these. So if you've been working on more modern calculators and computing machines, if you go back and look at one of these, you will see a lot of similarities in the way that they operate. So hopefully you found that series interesting. I've got some more vintage equipment coming up that I need to repair, and we'll take a similar approach, strip them down, try and get them working.